Welcome to Morehouse Metrology Matters, where we take an inside look at almost everything. Today, we're going to take an inside look at not only Mr. Bubble's bubble bath, though we're also going to take an inside look at load cells. And we have our design engineer, Mark Jones. Mark Allen Jones, he is a member of the Allen Group on Facebook. So that's a prestigious group of what do you want to say about the Allens, Mark?
Yeah, very elite club. I think there's
Three of us.
Waiting list. About 5 years. We're up to what, 4 members now or 3?
And we have septennial meetings, so it really does not take much out of your time. It's once every 7 years that you have to.
That's a pretty big
be
commitment.
Be willing. We are trying to get Josh Allen and Tim Allen in our group. Neither one has responded to responded. So I don't know what's going on with that, Mark. So instead of talking about the Allens,
I'll call Tim.
Yeah.
You'll call Tim.
You'll call Tim Allen. He's got that hit new show out now. So this is an interesting what we end up doing, and Lainey Prairie is with us today. Her birthday was going to be Prairie, and it became
became Lainey instead.
Well, it actually became something else, but you go by Lainey. So Lainey's with us here. We're going to try to make this a more lighthearted discussion about load cells and stress and strain and Young's modulus and all the fun stuff, and just throw out some terms. What other terms do we want to throw out there, Mark? Plastic deformation, elasticity. We'll just start. What else do you want to rumble with? Some gauges, some alloys. Just throw some words out, make people think you're smart.
If a salesman starts throwing those terms at you, I just go somewhere else. Yeah.
Yeah, but my nonlinearity is good. It's perfect. Nonlinearity. You can adjust your we can compensate that in the load cell to make the nonlinearity really good. That sounds like a good thing for sales. What else? What's a good thing? Also, the accuracy. So Mark has worked at numerous places, and we have lots of extra discussions. Like, how does one derive a specification sheet? Like, truly derive every specification on the sheet? Is there years of testing and research gone into every single piece on there, or is it based on more educated guesses?
So there's a lot of variation, but there's a lot of sort of uniformity that's developed over the years of how they're reported, and what's reported, and what is reported is usually what's easy to report and what makes it look good relative to the competitors.
Right.
So if all you know is what's on the spec sheet, you probably don't know anything about the load cell. Especially if you're new to the field.
Yeah.
We might know some things. You might know that it operates at a certain temperature range.
Sure.
You might know that it's a piece of metal and what it weighs.
Right. But it's hard to interpret how well it'll operate within those ranges. Yeah. Even looking at all the numbers on the sheet when it's specified. Because sometimes you'll see the word accuracy, but no one's ever reported an accuracy spec for a load cell that's a real accuracy. It's all under certain conditions, certain environments, and for the most part, outside of the calibration field, although that's really where we do a lot of our work on calibration machines. When you take one to the field, most people can't tell you how that load cell will actually perform in that field. We can give you some guesses on which ones are better, but it usually requires, most applications. It'd be good to have discussions. If you don't have experience, to have discussions with, engineers and applications people who's actually dealt with similar cases. And
so, what are train conductors? What do the train conductors of trains have to do with load cells here? No, I kid.
Load cells?
Well, that's
another very difficult application, rail car loading. Yeah.
Yeah, that's an
weighing.
engineer
Yeah,
from engineer. That
sure.
silliness that people used to say. Oh, you're an engineer. Oh, you drive a train. No, that's
Yeah.
just my
Like I
stupidness. But
said,
so
I just
here's
tell them
what
I'm a carpenter if they ask what I do. Yeah,
and then I
Yeah.
told you
it
what?
saves.
Then they're gonna want you to come over and help them with the house
It's
because
it's
everything
easier.
everywhere,
That
like
too.
It's easier than load cells. Yeah. Cool.
it can be. Just
Yeah.
do it till it works. I'll just buy more wood. I'll buy more
Uh,
materials, and yeah, because you got to scrape.
yeah.
So
How'd you end up dealing with load cells, Mark?
yeah,
How'd you become the load
Uh,
cell guy?
sure. I needed some more money for college, and another load cell company was hiring in my town. Worked out well.
so
Yeah.
your river caught fire, and you said, "Oh, I got to get out of
Yeah.
this river this Ohio River that's on fire, and
Yeah.
I
That's
gotta go work for a company that's not by the river anymore."
not by the river.
So, is this when you left your van down by the river when you went to work for,
Uh,
to load
uh,
cells?
I'll never
Which
give
is
up that dream. Yeah.
You gave up your motivational speaking that you were doing for load cell gauging and everything else, and so yeah, go on. I derail this,
Hmm.
but yeah, you started with pressure, right? You started with a company and worked designing pressure cells.
Sure. Started. I was started there drafting actually. Pressure engineer quit. Then the load cell engineer quit, and had to teach myself a lot of the stuff while I was working there and going to school. And worked there for a while. Then one of the other engineers that had quit there started his own company. And actually, one of the guys who founded it helped start that company and went and worked for them. Uh, Learned a lot more stuff there too. They'd all been in the field forever, back to like the old BLH days. And
Yep.
cool. And one of the other guys was actually used to run a strain gauge manufacturing company. So there was a lot of experience to gain there, applications and engineers. And because we did do a lot of custom stuff, we also learned it's pretty well rounded. It wasn't just learning about the load cell itself; it's how it interacted with people's applications. So that's a lot more useful than a lot of engineers get the opportunity to be part of. We weren't
so
just designing one thing. Yeah.
you're kind of the custom load cell guy. You're kind of the go-to at this point for that. Is that something that you've
Yep.
done like throughout your history?
Yeah,
Custom stuff?
it's
Is
mostly
it your
been custom, yeah, and a lot of different technologies. Uh,
The
is it
fads. What have been some load cell fads? Like we had fashion fads, like the bell bottoms that you wore in the
the
70s.
were there fads like trends?
There were. We know of Ted's. Ted's was and that
Uh
might be coming back. The electronic data sheet, but Mark and I've had
Mhm.
we could bore the end users forever talking about Ted's and if they're good or if they're not good and what you can do with them. It's just dependent on your application. Some people are trying to revitalize Ted's,
Yeah,
right?
it's not fads. Slightly different. There's been a lot of assumptions, that load cells are old technology and be easily replaced with like the newest thing on the market. Um,
That be
yeah,
piezoelectric.
yeah. I met with the guy who makes like the foil for almost all the strain gauges one time, and we were talking. He was like, thought he almost got fired because he like predicted like around 2000 that this load cells gauges gonna be gone. No one's This is so technology so old, so out of date. No one will use it anymore. And he like was sort of his lines that made that at the rolling place. They they sort of like were trying to slow down and not expand that lane, even though their demand wasn't going down. And then it was a couple years later that the explosion from China happened. They were started making a lot of load cells, and then they ended up like a 4 or 5 year backlog on making the foil for strain gauges. And it was a really tough market there for a while. You couldn't get anything like that. It was all bought up years in advance. So none of the fads have replaced what a basic load cell is, and part of it is, especially on the higher capacity stuff, you need a certain amount of steel just for the structure to carry
Right.
the load. And once you do that, it usually becomes strain gauge is the easiest way the most cost-effective way to make it once you have that big chunk of steel. On smaller stuff, there's some different technologies you've used, but they don't work well except for like specific applications. So I don't see the once you get over like a couple 100 pounds, load cells going anywhere in the near future.
I don't see it going anywhere. I think technologies will definitely come out, and we'll see new ones. There's people are laying wires on wings. They're doing other stuff to check, and it depends. What's so cool when I get to talk to Mark on the phone and just daily, it's Mark. You always come back with, well, what do they need? When I think Mark takes offense to me sometimes because I say, well, that's a bad load cell. The design isn't that good, and we test it out here. And Mark always comes back and says, well, wait a minute, our industry, which is the calibration industry. Yes, it's not good for maybe not good for what they're doing, but the general purpose, the people out there that care about measuring to 0.5% or 1%, vastly exceed those of us that are trying to get down to 0.1 or 0.2%. So, and then, right, Mark, I mean, that's one thing to talk about.
And cells hate me when like a customer wants to buy, they talk a customer into buying like a $20,000 load cell. And I'm like, wait, that application only requires a $2,000 load cell.
Right. And it's about risk and where people want to be. And it's a difficult, there's a process between rationality of $2,000 and just excessiveness of 20.
Yeah.
There's
and that goes both ways. Sometimes you're like, they're going to need a more expensive one when they get to the field. Yeah.
Well, all the things that compound here. So when we actually test and we look at, not the things on the spec sheet, we have a document out there on our website at MH4, some load cell specifications. People can read what nonlinearity is, what hysteresis is, what static error band is. But going back to that initial discussion, it was, people take the spec sheet. Engineers are out there and they're all like analyzing these spec sheets and what do they actually mean? And very few people actually give you what that performance of the load cell. And I'd argue that next to no one gives you the true performance of the load cell. What we give as a company, as Morehouse, we calibrate something at dead weight with dead weights, really, really low uncertainty. We give that expected performance of that device, especially when we do like an E74 cal or ISO 376 cal, at the time of calibration. Now, people go use this load cell, they're going to derate it. The thing I can say is at least our spec sheets do say, like, what are you going to get? What is that expected performance when you rotate your load cell? That, however, isn't enough for a lot of the end users, because if they use it on equipment that's drastically different than ours, then all these errors or the derating starts to happen. And more, this is where Mark and I have several discussions on this. This is where, what load cell do you need? What for your application? We could test an S-beam load cell in our lab, pay attention to alignment, pay attention to everything else, and get pretty good numbers. This is a load cell, maybe Mark's even bought some off of Amazon that have been pretty ridiculous as far as how good they were when we test them. Somebody else goes and uses them, they're not paying as much attention to the alignment, the loading conditions. They're operating in different temperatures. All of a sudden, a device that they think is good to like 0.01% is actually only good to 1% at best. And that's really where we get into this tricky line of what load cell is the right load cell for somebody to use in the field. Just because we can test it and it can look good doesn't mean that it's going to be that good in the field. And there are also, long question here, Mark, and long diatribe, but there's also those load cells that people buy that are cheap, and we test them and they look like garbage. And I can confidently say, hopefully all of us can, is that if we test them in our machines with alignment fixtures and everything else, and they don't look good, they're not going to get any better for the end user. And what I would ask you to kind of comment on, Mark, is the design elements, all this
Sure.
stuff that, yeah.
I mean, I have the conversation a lot with like the guys in the calibration lab that, you know, there's no way we can replicate what's in the field practically, or even know for every load cell. What we do try to do is make sure we test it here the same way, really consistently, and we can really check on the health of the load cell. You know, is it performing repeatably for the customer? Is it going downhill from the last calibration? Is it so? You know, all that work we do in our labs, not wasted. It's really good sanity check when we see the repeatability of stuff in load cells. So that's, you know, once you move outside of the test and measurement world, like where we use load cells to install them in other calibration machines
And calibrate other load cells.
Yeah. So we do that. It's, you know, stability. Yeah. So our lab's really great for those applications and finding the accuracy there. But when it comes to finding the application for general, you know, use in the field, you know, what our strength is, we can, you know, very accurately repeat, you know, the test conditions we tested it last time with. So that gives you a good test on the load cell itself, how it's performing in the field, whether you're going to get the same measurements in your process. Is it going to give you, and even if it's not giving the same absolute number, because you don't know what that is from our lab to there, it's giving you the same number over time. So you can set your process up based on that load cell and know it's not changing. But the things that can affect in the field are just unlimited. One of the weirdest things I've ever saw is we made a replacement for a customer for a different manufacturer on a load cell. And the only thing we made different is we put a better connector on it. It was a glass to metal seal connector, really high quality, you know, connector. And we sent it to the field, and they were seeing throughout the day, they were seeing up to 1% difference compared to the load cell they had in there in the past. So after some head scratching and a lot of testing, it turns out that these particular connectors, when they're in the sun or a large temperature gradient, didn't bring all the connectors to the same temperature. There was a temperature gradient across the connectors, and it was causing a thermocouple effect, and it was huge. So we had to go back with a cheap connector for that environment because it worked a lot better. And it's just how many little things, when you're talking about millivolt level signals, can affect it. Yeah.
And we've written lots of articles on this. Sure. You and I have gone over numerous things. You've designed countless things. One of the things that you designed, I was pretty amazed on, were shackle load pins. This is a weighing application, right? For intents and purposes, Mark has a really great design. We make it. We test it, and we're testing them comparing to other people's shackle load pins. And on the surface, it looked a little better. I'm going to say if we just put it in our machine, did some testing, never put it back in our machine, never did anything else, just putting it in our machine, and it looked better than most of them on the market. It wasn't a night and day, I would say. It repeated a little bit better. Though when you start doing things that actually matter, like let's take it apart, put it back together, and put it back in the machine, we saw a difference in rotating the pin and doing everything else. We saw something that was a magnitude, at least a third better than the majority of stuff that's out there on the market now. And Mark has a design that could get even better than that, though the cost would go way up. So you have a willingness to pay aspect. You know, what are people willing to pay for this? And you also have a performance thing, and you have a unknown, where most people that are using these for weighing say, hey, the manufacturer specs it at 1%, and I'm good to 1%. Well, our testing, we know that they're not good to 1% if you take them apart, put them back together, and invert the pin. When you were designing this and when you were testing this, what are your over thoughts on overall thoughts on that in general. The concept of manufacturers spec something, and we know that that spec is one of those things that's only achieved under ideal conditions and really doesn't replicate the actual use. And then you come
Yeah.
and make a better product. How do you but your better product, people don't know that it's better because they don't sit there and do these tests. They don't say, "Oh, I'm going to repeat weigh this. Let's take the crane down, put it back in, and weigh it again. Oh, why do I have this large deviation?" They don't test that.
Just a quick comment about, manufacturers. I started out a manufacturer who they made a lot of different load cells, and restart that. When it comes to specs,
Yeah.
They would sort of tell themselves they were shipping good load cells because they were trying to, if they could find a way for it to sort of meet spec. I mean, they would try different loading conditions, put paper
Oh
under the
yeah.
load cell, adjust the
Yeah.
machine.
Yeah.
They thought, if they could somehow trick the testing into making it meet spec, that they weren't being deceitful and they were shipping out a good load cell, which of course it doesn't meet that in the field if you have to do all that work to just on one test get it to pass, you know. And I've seen some places, they'll, because load cells have some creep, they'll like sort of time me when they take the measurements just so they can print out the cert that says it was right. So, even some of them think they're doing the right thing, and some of them know they're not doing the right thing. It really still is sort of the Wild West out there when you go to like a random group of manufacturers, even some of the
Mhm.
bigger names. Yeah.
Yeah, and there's no
But yeah,
guarantee. And then they switch
right.
vendors too.
Sure.
So material into
Mhm.
that material
Yeah,
lots are
material.
so important. The type of material you use. We were dealing
Sure.
with. We made a 1,000,000 pound load cell the one time out of a Viscount 44. It was one of the weird. It was before you were here. It was one of the weirder materials, but the results were pretty good. And then Mark builds a 1,000,000 pound multi-column load cell, and the results of that cell are 3 times better than the one we made before Mark was here out of Viscount 44. So what I'm getting at, even though we use this specialized material for thinking we were going to get that much better, when you come along with all your knowledge, you go, "Oh, here, we'll just do this in a multi-column cell, and I'm going to design that." So what goes into this whole process? Because there's so much out there for people to look at when they're actually buying a load cell or picking a load cell. And they don't really get to see the design aspect of the stuff that you go through in your knowledge. I mean, we don't. I get to work with you, which is cool. Lane gets to work with you, really really cool. But we don't get to go inside your brain, whether we want to or not, and see all of this. I mean, I can't imagine all the. I mean, SpaceX, what they say, fail fast, and learn from
Mhm.
it. All the stuff over those years to get those designs, it's not simple, right? Just
Yeah. It takes a lot of failures, or, but
yeah.
those, like I was lucky enough, to have worked with some of the guys, like including like Vance Stooling, who'd been in the business since, well into the 50s, and part of a number of companies, and like I said, a number of other people had a lot of experience too, already been through a lot of the failures, and then working with custom stuff. That means you get to try a lot of new products, and you get to try a lot of new things, and that's it's really good for getting a well-rounded experience. There's all those spots that some people like really specialize in a certain load cell, and they may know that a little better, um, but knowing all, being able to work both with the industry and the design, and know, even though you're using the best materials on like one load cell, if you don't also have the design and the loading conditions in mind, you can use maybe not as good as material on another load cell and get better results. It's all the factors play in. There's not just a single, there's like these 1,000 different factors, and that sort of, you don't have a list, but they're certainly in your brain,
Hmm.
from your experience and other people's ideas you've stole from,
Well,
yeah, yeah.
that's a good thing because you have. I
Mhm.
mean, somebody has a design out there. Not many are patented. right? Overall, like if we wanted to make an S-beam load cell today, does anybody hold a patent on a general S-beam? Almost everybody can make
Mhm.
them. Anybody starts making them, right? You don't want to infringe on some of that technology, but there's not, I mean, what? A single column load cell. What's the
Yeah.
benefit? Where's a patent on I'm going to machine some material? I'm being really
Mhm.
rough here. I'm going to machine some material. I'm going to stick some gauges on it. I may or may not temperature compensate it. Of course, we do, but we know some manufacturers that do not. And then I'm going to try to replicate this process X number of times, where each time I could machine it just a little bit different. Each time I could gauge it a little bit different. I mean, there's so much stuff that goes into this.
Yeah. I've never ran into any problems with anybody complaining about infringing, but I see those patents out there where they change one little thing, like maybe they'll run the wire a different way and it
Yeah.
doesn't really affect anything. But I could
And
see
now it's a
if,
patent.
yeah, I don't know if they did that just to get a patent to look good in the company or if they were looking to become a patent troll on other companies. Not sure.
It's a
Yeah.
tough if it's a tough piece
Yeah.
because you can waste your life chasing patents and trying
Mm-hmm.
to be wealthy. I don't think our
Mm-hmm.
industry is doing that as well. The measurement industry, because no one's going. I shouldn't say no one. Very little manufacturing and the test and measurement equipment specifically for load cells are gearing towards the calibration laboratories that want to maintain several parts per million, right? In general, if I wanted to go
Yeah.
out and buy a load cell that I said was accurate, would repeat within 10 parts per million at 1 million pounds, I might be able to get that. I'd probably raise a lot of eyebrows in the
Mm-hmm.
process, and then I'm going to tell them not only do I want to get that, I want NIST to test it, right? And I want
Mm-hmm.
to be rotated and put in different conditions and meet that condition. How many people are going to be interested in listening to me out there, Mark? I know.
There's
Yeah,
there's guys that'll certainly say they can and I'll sell you
yeah,
one, but a lot of them know that you probably can't prove it unless you do go to NIST or us or
yep.
somebody with some primary dead weights.
And
Sure,
in that
but
regards,
yeah.
it's a gamble for the company, so the price is
Hmm.
going to go way up. And do they
Sure.
even want to take it on? What we've seen recently is a lot of companies they come to us because no one else wants to take it on. If you have a special
Hmm.
request, you want to go talk to some of the bigger manufacturers, they don't care. It's a one-off. It's going to take how many engineering hours? And then it's got to be
Hmm.
right. And then if it's not right, they're going to lose money. So it's not a really profitable
Hmm.
field as far as custom and one-offs.
Yeah,
So yeah.
I've seen over the years, the past 25, 30 years, it's really, just in business in general, is getting bought by larger companies, and they don't want to deal with the one-offs and the
Mhm.
small customs. They just want to sell you
Definitely.
the most expensive thing they have that fits your goal.
Mhm.
And a lot of times, we can by making a custom load cell, we have experience with all different technologies. We talk about strain gauges. We can
Yep.
deal with um, thin film strain gauges. We can deal with silicon strain gauges designs. Some of those, like the thin film, is working with other companies, but we can do the design and have them help with the gauging and stuff, or the sputtering. But just having that option to, you know, meet a customer's needs instead of not trying to push the two or three products we have onto the customer, can be a big advantage. And sometimes, even though sometimes a load cell costs more, but the customer's making like $2,000 in fixtures to adapt their load cell to that process.
Mhm.
So a custom load cell can save them money sometimes.
It can,
Yeah,
especially if they want, like, there's things like load pins that you can design that, depending on the way they're loaded and everything else, that
sure.
can play a big difference. Sometimes it makes sense to buy something commercial. Other
Mhm.
times it might not. And this is what we see a lot of in the lab. Somebody buys something commercial, they paid a lot of money. Maybe they didn't pay enough money. Maybe they bought something cheap, but then it doesn't calibrate. And then what do they want to do? If it doesn't calibrate, they want us to somehow make it calibrate, right? Because they've already spent the
Mhm.
money, or they're gonna
Mhm.
or they're gonna live
Sure.
with
Yeah.
something that's not as good as what it was supposed to be. And then you start saying, okay, well, if you want us to make it calibrate, let's talk about adapters. It's so critical. Like we'll design bottom plates, top plates. We'll start going down this rabbit hole, which sometimes does work. I mean, if you add a top plate and a bottom plate and you focus the load and everything else, and you send it off to the customer and say, this is what we got. Make sure you load it with this. Make sure you align it. Uh, is that good enough? I mean, that's a lot of money after the fact for us, a lot of testing after the fact. That if they would have just bought something, talked to us to begin with, they might have got there sooner with less expense. And then we get into, sorry, I'm ranting, but then we get into the stability. So you said something where it comes back the next year. And we have load cells out there. When I did this load cell analysis, we have load cells out there that I can't wait for them to come back. They're like a sanity check for us. Like every year, it's 0.002% drift, and it's just awesome. That's 20 parts per million. And we have load cells that come back where that aren't from us, where it's like 0.1% or 0.2%, and someone sold them something and they said it was as good to 0.5 or good to 0.1, and it never is. But that's you said something, and I do want to get to more stuff here and ask Lainey. I found out that Mark and I have so much in common. We both like sputtering.
What I'm noticing is I've been sitting here wanting to ask Mark if he has a favorite load cell. Because like this love of load cells, where you get like super duper stoked and enthusiastic, like you can't wait for that load cell to come back. Wondering, I know.
A favorite one?
Yeah, do you have a favorite, Mark, or like a favorite project?
I have a least favorite load cell. That helps.
Yeah, what is it?
Yeah,
that was always load pins.
Oh, load pins are your least favorite? Yeah. I was gonna say any load cell that has the Michigan Wolverine colors on it is his least favorite, and his favorite is anyone that has the Ohio State colors.
Ohio State branded load cells.
I used to hate the LeBeau load cells till they got bought and moved to Ohio. Columbus,
then
Ohio.
You love
Ohio loyalty.
Yeah, cool.
Deep.
So there is an Ohio bias in everything that you do or say. But what would be your favorite one? If you have, like, mine's the shear whip. I just, if I'm gonna pick something, I'm gonna pick be below 100,000 and below. I'm gonna pick a shear whip. Just because it's the majority of times it's going to calibrate. It's going to calibrate really well, and we're not going to have any issues with it. Is it the best load cell in the world? Probably not. But what are you going to pick?
I'm pretty partial to cantilever load cells, like the ones.
Cantilevers?
We don't see them as much here, but you see them a lot in scales.
Yep.
And they can, and because they're pretty consistent, and they're pretty mass market, you can get some pretty nice performance under set conditions, but they can be really flexible for the lower range stuff. And pretty forgiving for off-axis loading and stuff like that. That's why you can put one load cell on a scale, and you can load it in different corners on the scale and get pretty decent performance. It doesn't scale up well, past 10,000 pounds or so, but in the lower ranges, it's really nice.
What's your favorite project you've worked on? Because I feel like you're the load cell guy, but I think that your favorite project might have ended up being the dead weight we built in Ohio.
That's probably the favorite project from here. Learned a lot, different things. Got to work with a lot of different people. A totally different scale. I'm used to making things you can hold in your hand, and we were making something 30 foot tall. Took up a whole new building they built for it. Good learning experience too. Yeah.
Wow.
Yeah.
You would have thought you would have hired someone who knew what they were doing on that project, but
you were great.
That often.
That was an amazing project. I love the idea of something existing there. Yeah.
And there's a good chance to get back to Ohio on the weekends.
Yeah, that Ohio bias comes through again.
Yeah.
Oh, I was looking up some cantilever jokes that are bad.
Bad jokes, some puns.
For bridge enthusiasts out there, I think my ex must have been a bottom-supported bridge with a track running down the middle. Cantilever alone without someone running a train on them. Work in progress. Needs fine tuning. Yeah, just stupid. Like there's no good cantilever jokes. I don't even know if that one made any sense. So the stupid
Mark's gonna use it
cantilever
at the
jokes.
bar
But
later.
Mark's gonna
not
use some
a
jokes
good
about.
lot of good load cell jokes out there.
Is
In
there? Are
general,
there
yeah.
some good load cell jokes out there? Have you heard some good load
I
cell
have
jokes
not.
that you want to?
No.
Yeah. So yeah, these aren't. I don't know if there's any. Uh, no, I've not heard any good load cell jokes. Maybe somebody has one out there. I think our we have probably one of the most dumb ones that we've said is why is the load cell so stressed out? You want to know the answer?
I do.
Because it was overloaded.
Oof.
As Mark
Yeah.
hysterically laughs without anybody hearing in the background, we'll resume.
Mark's a very
That one
noisy guy. Yeah.
is very noisy. No, application wise. So what there's a lot of stuff that's we bounced around, but someone out there looking for a load cell, besides calling us, what and not really looking at the specification sheet because you may or may not be getting what you want. Do you have any advice? I mean, it's kind of a world where we're saying specification sheets for the most manufacturers don't really tell you that much. Like, what's somebody gonna do?
It's this is a good question. It's hard to sort of get a feel for it if you haven't worked with load cells before. Harder than I think it would be, but from my experience, it is. For most engineers, but unlike most companies, we actually like to talk about load cells here. Pretty much everyone in the company, and you can pretty get a hold of it. Most of us, if you try, pretty easily. You can call sales. Usually available to talk. An application. I usually learn something. You usually learn something. Hopefully, we have a customer that likes working with us at the end of it. But it's hard to get a feel for how load cells perform until you've actually worked with them a little bit.
And even then, you
Yeah.
have some surprises.
Sure. Yeah, there's not. There's some books out there on some applications. You read them, you think you know something, but they don't really give you like really practical stuff for general knowledge. Or a lot of times, we've worked in so many different industries. We may know what you want, even if you don't know all some of the things you're gonna have to think about for that application.
Yeah.
That's a good point.
Sure.
And you find little things, right? It's not always. I think there was one story. I don't know it specifically, but it was a bridge. It was a bridge, and someone said this bridge is awesome, and someone else don't know, and someone else said I'm gonna hire this person to build the same bridge in a different climate, in a different atmosphere, and that bridge ended up failing. And it ended up failing because the winds where they built it and the temperature constraints or the temperature were vastly different. The conditions were vastly different. So load cells are kind of similar, I think, right? If you have knowledge of them, that just because it works for one application doesn't mean it's going to work for another. An easy one like button load cells are all over the place. If I need a button load cell for a scale, it might be to weigh myself. That's going to be a lot different than if I need if I'm expecting that button scale to do something with a lot more accuracy. So
sure. And sometimes, it's not even just understanding the load cell. Sometimes the load cell can work fine, but it's not obvious how the forces. You're not used to thinking about how some of the forces transfer in that application. And sometimes you can get, really different results than what you're expecting because you're not understanding how the loads are flowing through the parts. So we have that a lot because you mentioned the small load cells. It comes up a lot, and especially the through-hole load cells where they use the bolt stuff together. It's really weird when you start tensioning some load members and adding loads on top of that. Yeah.
Well, and then what they do in the field, they put a bunch of wire rope, right? Not wire, cables through it. and an adapter, and they pull on it. So it's very hard to replicate that by us just putting a ring inside of it. And they're going to get all kinds of side forces and everything else that we're not even going to see.
Yeah.
So we're going to give them expected performance when they load something at a temperature, when it's aligned and everything else. Now they're going to put it horizontally for the most part, run a bunch of cables through it. These are the through-hole load cells, right? And try to make a measurement, and then put some adapters on it. I think someone told me there's how many strings of cables sometimes they run through it, and that's a whole nother another mess. But this is a very mechanical. Us doing force and torque is very mechanical in nature, and almost anything interferes with that and the load cell design. If you make something a few millimeters higher than the last design, you could have drastic change in output. Maybe better, maybe worse, right?
Sure.
What are some of the other things out there that you've seen just in general as far as manufacturing load cells and the progression on how do you keep making a better load cell?
It's a good question. What I think seems to be, I mean, we have a certain level most customers are willing to pay for as far as performance on a lot of stuff. And the SureWeb's a pretty good, like price versus performance load cell. It's it's a really nice load cell when that comes in for, like you said, price versus performance.
Well, and we have
yeah.
Yeah, and that we have a stainless steel one that's a budget one that's actually cheaper than the steel ones, and the designs are slightly different. So the performance is similar.
So that's what sort of where I'm going. Once you're in that where you need like an accurate load cell, but not like a reference standard per se, in that area there, then what really becomes important is the quality of the load cell itself, how it's put together, just little things like whether it's welded for that application or not welded, what it's going to do in the environment. What stands apart then, once you get to like a certain load cell, it's been around for 50 years and has a certain level of performance, as long as the company's paying attention, is the reliability of that load cell, and that can set out a certain one company's product versus another, just how reliably they produce it.
Right. And just because you made it right once one time doesn't mean you're going to make it right the second time.
Sure. And then
that's the other head scratcher. That's one of the biggest head scratchers we had, because we had one of the designs that built so many of them and then changed it a little bit, and now all of a sudden you take it, you put it in a different machine, and you get a slightly different output. And that's one that you and I talked to, and Laney as well talked about, and said, okay, for the metrology, the reference standard, it's not a good enough load cell. So for general purpose, it's a fine load cell. So we're here sitting on a lot of these that we had to rework. Well, we actually had to remake, and then we have this lot that's just not good. So testing is critical. We've talked about that, but it's also not always guaranteed that you're this type of, that every load cell is going to perform the same way. If you change anything in there, you could change something else.
So that's
difficult. Yeah, go ahead.
That's the best thing about working here. Making load cells here, we have access to basically the better test machines than any other load cell manufacturer, certainly on this continent. Right. And so, when we go to test it, we don't have to think about, is it the test machine or the load cell? We can see if that load cell is performing right. We have the history on it, where most manufacturers really have to question their reference standards, their load cells. They don't know if they're making the same load cell from piece to piece. So that's it's a real luxury with the equipment we have here.
Yeah. So for the people out there that want to know, if they don't, if they do not have the same equipment we do, what are some checks they can they can do to know their load cell is decent, besides a load cell tester. I'm going to name, we have a load cell tester that'll test a zero balance. It'll test shield the bridge, all that stuff, mega the insulation. It'll do all that stuff. So that's a tool that's available. Multimeter, you can check the bridge resistance. What if they can physically load something? What are some of the things they can look for? Testing.
So one of the tests I like is not. Sometimes you don't know how well it's loaded when you're loading full scale, or what load you have, or if it's applied exactly the same way. But usually you can relieve the load, and that'll be under the same load conditions every time. So this concept that we talked about, zero return and things. So usually you can apply a load in the field, and maybe it's a little higher, a little lower the next time if you're using hydraulics. But when you let it off, you know you have the same load on it. So you pay attention to that reading when it comes back. You can see if it's stable. Like if you load it multiple times, does it return to the same number? Or and there's another test. You can load it for like 20 minutes or so under the higher load. Then you let it off, and you can sort of judge your creep of your load cell. So that stability with the zero return and maybe creep is sometimes a good check on the health of your load cell beyond just checking like resistances and outputs.
That's a really good test, because if that's not, if it's not coming back, and there's certain specifications for it, what creep recovery, and then there's under load, and it's a lot easier to check it at zero, to load it to something close. Pull it off. What do you, generally people like the ISO standard says check it at a minute and compare a minute with 600, or now I'm drawing a little bit of a and compare the minute with 300 seconds, 5 minutes. So check it initially after, I think it's 30 seconds, and then check it again. I always like to check it every 30 seconds up to X number of time frame and monitor it down. What do you recommend on that?
I think the really important is being consistent on what times you do check it as, and then doing it multiple times so you can see if it's repeating.
Well, okay, so how do I know if I have a good load cell or a bad load cell? Because I'm going to check this, and the mini multi-column load cell that you designed, I put a 4215 on it. That I do that creep test, and it comes back to 3 counts out of like 300,000, roughly. I've done numerous tests on that cell. That cell has great creep recovery. So if somebody suspected that cell were bad and they did this test, it would work for them. But if they're just evaluating other load cells that they have, what's a good number and what's a bad number? My number was that 3 out of 300,000 counts is super freaking low.
It's it's tough. You just sort of got to get used to your load cell and your instrumentation, because they both can affect it, along with even the environment, the weather. Is a load cell setting in the same position when you read it? I mean, so some load cells have better creep than others. Some have worse creep, but they're still going to last 10 million cycles and give you the performance you need. If you're in an environment, it's you got to sort of know what that load cell does. So in addition to the creep, doing the same creep test 2 or 3 times, or just the zero return and measure and just at the 1 minute mark every time, having that repeat over 5 or 6 cycles, that repeatability is a good thing to know, where even if a load cell creeps more or less, if it's repeatable at the same time, that's a more generic test. When you talk about how much creep, then that depends on your load cell and what you're using it for and how good it was when it left the factory. And that can vary. The 20-minute creep time can be like, from 0.1% to 0.1 to 0.15% on some load cells, and still, that's just because not as much time was put in the material or the gauges matching up, but it works fine for some applications.
Yeah, if I just wanted to check a press, what's that matter? Like I'm just checking a stamping press. Does that matter?
I'm not an expert on how close you have to control that, but if you have to control it within 1%, you're probably not too much worried about the creep if it's, if it's just repeating measurements.
Mhm.
Yeah. So, you take those readings at every minute when you do the zero return, and it's pretty consistent, and it's well under 0.1%, for your 1% measurement that you really need. So yeah, so knowing what, a lot of times we have customers that come on a load cell, they say, oh, just give us a 0.01% load cell or something, or 0.02 linearity load cell, and they have no idea that that's not accuracy in the field, or how
Nope.
much it would actually cost to really achieve that accuracy between the lab and the field.
Right. And that's not repositioning, rotating. Some
Yeah.
other test you can do is you can just load it
Yeah.
to the, if you don't know your load, creep is a great 100%.
Sure.
That's great, because if you're not, you can't repeat then, and then that makes it hard to do a repeatability test. If I can control the force really well, I can do repeatability. You can do some timing. If you rotate the load cell and it looks like an entirely different load cell, that's a bad thing as well. And sometimes I found out with some manufacturers, they spec everything, though they never do that. They never rotate it. And no machine is perfect, right? You're never gonna be plumb level, square, rigid. To some extent, you're gonna be off. You're going to have misalignment all the time. You're going to have side load all of the time. It's just how much. And we're talking, we can go in our machines, we can go real low. Though in some field applications, it's not as low. And then the load cell looks a bit different. And that's a inherent design problem, right? That you have to pick the right material, the right gauges. You have to lay those gauges. You have to do the heat treat. You have to do all that fun stuff that comes into it. Right.
Yeah. And so that means there's like 1,000 steps, and each one of them is almost as critical.
Yep.
Some of it's just timing between one process. It's insane. And when things do go wrong, it's really frustrating to troubleshoot sometimes, because there's no documentation of what went wrong, because it's just some random process in there. We had problems at one place, with people using certain hand lotions that had acidic acid in the base, which caused pretty severe corrosion on gauging tabs.
Okay.
So
Yep. So that's a
things,
hard one,
yeah,
because
sure.
I can see someone might say, oh, it's just a bad load cell, until you find the problem that someone was using a different an acidic hand lotion.
And these
Crazy
things you
stuff.
didn't see right away. You didn't see them
Right.
to after they were like in stock for like 30 days or so. Yeah.
Oh, that's another fun one, when you see something like that comes in soaking wet, or somebody didn't seal something, or rusted. There's so many things out there. I guess as we wrap up and let Lainey ask you some questions, because we do have other questions for you. We have questions on how frequently do you wear your Mountain Dew Snuggie blanket that Lainey got you when you're cold?
Given the temperature in this office, it's about 90% of the time.
He's being awfully stubborn over there.
He's not being
Um,
stubborn.
Yeah.
What do you
I
have?
was
What do you have to ask him?
I was noticing he still has his Cool Hand Luke picture, I think, taped. I can see it on his desk there. Is that still your favorite movie, or do you prefer Shrek?
That's definitely the favorite movie. Shrek might be the most
Shrek
fun
is.
movie, but
Oh, that's
So,
fine. Oh, Cool Hand Luke is the classic.
out of
it's
all the
classic. Yeah.
breakdancing
I
movies,
don't think
what
anybody
one's
could
your
argue
favorite?
otherwise.
Out of all the
What?
breakdancing movies, out of all the breakdancing movies that you watch all the
Just
time, what one is your favorite?
the classic head spin, right?
Headspin, not Breaking
That's
Two,
the favorite
not the
move.
electric boogaloo. That's a movie. What else? What else do you want to say to people out there? You want to profess your love for Mr. Bubble, and the awesome bubblegum smell it leaves you with after you have your
It's that pink stuff, that classic pink bubble bath. Is that what we're talking
yeah,
about, Mr.
Mr.
Bubble?
Bubble, Mr. Bubble, yeah, yeah,
Oh,
yeah, yeah. We want to
You're
bring
not
it back.
following the conversation, are you?
Yeah, no, yeah, no. But Mr. Bubble, Mr. Bubble is. Have you used Mr. Bubble to clean load cells? Does any load cell? Have you made a load cell that has a bubble gummy smell to it? The answer is probably no.
I've used some pretty heavy soap to clean out some large load cells sometimes.
Yeah, and none of it smelled good.
Put that
I take
Mr.
it.
Bubble in the power washer. You can clean the potting off some pretty good sized load cells.
Power washer.
Sweet, Mr. Bubble
The
has
Ohio
multiple
Yeah.
coming through there.
applications. So, does Mr. Bubble catch fire if you dump it in the river?
Did the river catch fire?
Yeah.
Was it just like people could light the water coming out their spigot?
No, it caught fire. It caught
It
fire.
was-
Did it?
Yeah, Cuyahoga
Yeah.
Falls caught fire several
Oh my
several
goodness.
times.
we-
So it gets that rap.
That's
We joke about.
nightmarish.
We joke. with
Yeah.
Mark on
Cleveland's not that big of a part of Ohio. It's just up there in the corner.
Yeah, it's
It's
not.
just
we don't wanna
hugely
say anything.
significant and
Yeah.
large.
Sure. Yeah.
There's a lot of labs coming back. What else do you want to say as we wrap up? Lainey, you have anything?
No, appreciate learning more. Every time I talk to Mark, I learn something.
That's what's cool about having the team and working with everybody is you learn more and more. And when you get to try to figure out people's applications, I mean, our goal is to be as honest as we can. And that means, that's exactly what it is, to try to find the right load cell to match with their application. Sometimes we don't have it, and sometimes we'll pitch an alternative. So, and other times we do. Sometimes Mark will want to make it, but it won't make any sense. That's not. How many times does that happen, Mark? That's been not that many, right? Usually we find a commercial, something commercially available.
Yeah, I don't. Yeah, we pretty much, except for some very strange applications, we can supply load cells for pretty much most applications. Anything anybody wants, we can make them available. Yeah.
Yeah, we just did some for rocket testing. We've done some.
Sure.
Yeah, that'd be another conversation. We'll save that for another day.
Yeah.
2 versus 3 and thrust engine testing and very specific questions for
Yeah.
or 2 versus 4 and just structural stuff.
Yeah. Outside of the commodity market, like if you're putting them in like, something people are buying millions of, that's not our price point. But you may use other stuff. We could talk to you about, what are some good manufacturers for that if you talk to us too. I mean, there's a whole slew of good and bad people out there doing stuff. Yeah.
We're very transparent and very open with it.
Yeah.
Or there are some manufacturers that we'll recommend almost immediately. It is very difficult to find custom application people that are willing to take on the custom application work. So, but Mark will at least look at it, so that's good. What's up, Lainey?
I think Mark just enjoys solving those puzzles. He gets the thrill out of
he does
the custom work because of that, I think.
He does. Right now he's working on automating torque machines, specifically single arm and dual arm torque machines with a load cell that can go out. That's been a fun project, a detour, the amount of torsion and errors, but we can talk about that another time. If anybody has interest, they can certainly reach us.
Sure.
How do they connect with you, Mark, if you want them to connect with you on LinkedIn? So on
they can LinkedIn, call the company, ask for me. Sure.
Ask for Mark Allen Jones. Sure. You want it to be.
Yep.
Okay. So there you go. So thanks, Mark. Thanks for the discussion.